Hello, this is the recording for Team 11's Red Wine Quality Project, final project for computational thinking. My name is Diego Romero.
I'm Jacob Perez.
I'm Mason Keller.
Okay, so to begin the video, this part of the code right here just shows we imported all the necessary libraries we're going to need for the code to run and everything.
In this part of the code, it loads a data set from the red wine quality file and shows the first 10 columns of the data frame. In this part, the code provides an insight into the structure summary statistics of the red wine quality data frame to gain a better understanding of the characteristics of red wine quality data set.
Yeah, so in other words, this first part, it just gives us some of the info of the different features in the data set and giving us some of the null values because, well, if there was any missing values, it would affect the data and the code later on with the linear regression model. Like Jacob said, it also describes us and gives us summary statistics. So this is where that's at. Gives us the mean STDs and the max, some different just statistics for the different features.
And right here, this code gives us an array with all the unique quality values of the red wine data set. And here in this next part, the code gives us if the wine quality is 6 or more, it would be considered a good quality wine. If it's lower than 6, it'll be just a quality wine.
Yeah, so this code just simply runs, just so in this case we have 10 different data sets, and basically if the quality of the wine is a value of 6 or more, it'll be considered good.
In this part of the code, it plots to generate a visual representation of the distribution of quality scores in red wine data sets. So as you can see, it mostly between 5 and 6. Those are the main quality scores that are given. In this part of the code, generates histograms for each feature in red wine data frame, providing a visual representation of the distribution of numerical figures. This part, it generates a heat map to visualize the correlation coefficients between the different features. It helps identify which feature are positively or negatively correlated with each other, aiding in understanding the relationship between the features.
So basically, as you can see with the heat map, the positive numbers obviously show the positive correlation between features, and the negative numbers show the negative. So for example, between, you can say, residual and fixed acidity, it's mostly positive, but in some other cases it's negative.
And then this part of the code, it calculates the correlation matrix to understand the relationship between different features with numerical values, kind of just like the heat map, showing different positive and negative correlations. This code generates scatter plots in each subplot of the grid, which visualize the relationship between two features in the data set.
Yeah, so in other words, each row right here is one feature, and the scatter plots of each one is just basically visual representation of between two different variables. So for example, one of these scatter plots could be the scatter plot visual representation comparison between density and alcohol, and it shows the relationship in the scatter plot. So moving on, this part of the code basically, we're going to standardize the numerical values in each of the original columns of the red wine quality data in order for their values to have a mean of 0 and standard deviation of 1. And basically we're just standardizing the original columns to the standardized columns in order for that the standard deviation and the mean are all the same value. And here obviously we have a table to show it. As you can see, it's between 0 and 1, the mean and everything. This part of the data basically is a visual representation of what we're trying to do here, and as you can see, we have different numbers and values to represent that. And then moving on, this is where we're going to split the data set and identify the variables. This code prepares the data for testing and separates the data set. So here's where we begin to build the linear regression model as needed. So in this case, in this data right here, we identified the variables of x and y, and we printed out the range of the training set and the testing set, and we even showed a little bit of the x train head, which basically shows the different values and stuff, and the training part of it. And then moving on is where we have the correlation with specific variables. which in this case, this code attempts to analyze the influence of specific features that are given by the dataset on red wine quality used as a linear regression model. So the model we chose to build on is the linear regression model. And this code basically shows that. And as you can see, to run it again, we just enter a variable. So the variable we chose was alcohol. And we enter it, and it gives us a coefficient of variable and the mean square error, which is basically just the variable of interest of how much effect or the relationship between alcohol and the quality of the red wine. And this code right here is just a visualization of the linear regression model. So the visualization we chose is the regression plot. And in the regression plot, as you can see, the line right here is the regression line. And then we have the different plots showing basically the quality levels, the effect of alcohol on quality levels. So the higher level of alcohol, sometimes it's higher quality wine. For the most part, a mean range of alcohol is around the same quality for wine, but this just visually represents the linear regression model and through a linear regression plot. And then moving on for the last part is the data input user interface part. This code creates an input user interface code where you enter values for the features, uses the linear regression model that we trained before, and provides coefficients, intercepts, and allows the user to make predictions. So for example, I'm gonna run this code again, and we just enter values for each feature that we have in the red wine. So we can either do 5, 6 to make some good quality, 7. So we just put random ones, and at the end it gives us a prediction of the wine quality, which in this case is this value. And this just basically gives the user the free will to basically using the regression model we built and this different visualization in order to get a value to predict the wine quality of it. And that's basically what the code does. Moving on, for our intern report, our selected project title was Red Wine Quality Project. The general plan role assignments, I did the data analyst part. I helped in data acquiring, and I wrote the code and built the classification model. Jacob?
I did the literature review and aided in the data, finding out more data information.
I did the data acquisition and helped with the literature review with Jacob.
All of us collectively also learned from the literature review in order to build the code better and helped write the code and everything. And for our plan, basically for a good 4 or 5 days, we worked on writing the code, doing the literature review, seeing what we can learn from it, crying the data sets and putting together the analysis for the data and building the model together and making sure the code works. And on May 1st, like today, we made the presentation right here, and we recorded the video, which we're recording right now, to submit. Thank you so much for presenting.